Hey class, so here's the first question that you all are asked to tackle. We're told that we have this elevator that starts from rest, so down here V initial is 0, and then we're told that it speeds up at a constant rate for 2 seconds. So from 0 to 2 seconds we have a constant acceleration, and it's a positive value because it's speeding up. Then from 2 to 4 seconds, it maintains that speed. So if we call this, A2 is 0, if this is A1. And then from 4 to 6 seconds, we have an acceleration again that's still a constant rate. However, it's negative because it's slowing. And then we're asked, what would the normal force acting on you inside of that elevator be during each of those different segments? So again, if we think you're standing inside of this elevator in each of these situations, what is the normal force being exerted on you by the ground? And you get the idea. Probably I don't need to draw a person in each of these, but apparently I can't stop myself. Okay, so there we go. So just like any other force-related problem, you might have an intuition, you might be able to guess, but we should always trust the process and do the process. So let's draw a free body diagram for us inside the elevator in each of these different circumstances. So if we think about the first situation, for us, as we're just standing there in the elevator, we're going to have our weight going down, and we're going to have the normal force acting upward on us. In situation 2, it's going to be the same actually, the weight going down and the normal force going up. And in situation 3, we still have the weight going down and a normal force going up. So at first glance, again, we might think, oh, well, they're going to be the same. Whatever it is, they all might have the same answer. But we must include that acceleration still. So again, thinking back to what we were told, in this case, we're going to have a positive acceleration. In this case, the acceleration is 0. And in this case, we're going to have a downward or negative acceleration. So then, now to prove our conclusions that we're about to make, we can do sum of the forces for each of these circumstances. So again, sum of the forces in the y must equal MAY. And we can again use Newton's second law in all 3 of these cases to prove our conclusion. So in the first case, and in fact in all 3 cases, I'm just going to shift up a little bit here, all we have is the normal force minus mg equals ma. So in this case, that's m times positive a. Over here, what we have is the normal force, oh, excuse me, sorry, touching this with my hand. We have the normal force minus mg equals 0, since a is 0, and in the last case we have the normal force minus mg equals m times a negative a. So in each case, if we solve for, or compare, I should say, the normal force to the weight, in the first case we have the normal force equals mg plus ma. So our normal force will read something larger than our true weight, because the normal force, the ground, is pushing up to support our weight and giving us additional push to accelerate us upward. In the second case, the normal force will just equal mg because all it has to do is support our weight and nothing more. And in the third case, the normal force would be equal to mg minus ma, since that acceleration is negative. So in that case, the normal force would be less than our weight, because it doesn't even have to support, the ground doesn't even have to support our full weight, because gravity is partially being used to slow us down as things slow in the elevator. So once again, you can see the correct answers are Fn larger than mg for stage 1, Fn equals mg for stage 2, and Fn is less than mg for stage 3, as we proved down below. Hope that helps. Have a great day.